All right, good afternoon. I'm Don Bailey, and this is Greg-Roth. We're both security geeks for Amazon Web Services. I'm part of the AWS security team. My day job is protecting customers in AWS itself, and I lead and participate in a variety of our security engineering, operations, and threat intelligence efforts.
And I'm with the identity and access management team. We bring you identity and access management, multi-factor auth, as well as are responsible for designing and operating a lot of the API authentication and authorization within AWS.
And apparently deity-like voices as well. Today we're going to be talking about intrusion detection in the cloud. So, why should you care about this? Change management monitoring, we like to think that that's a good thing. Perhaps you have moved from being a one-man show or a dev shop. Maybe you have multiple admins at this point. You have contractors, you have interns. It's prudent for you to keep an eye on and be aware of changes in your AWS environment. Now, traditional intrusion detection mechanisms, largely host and network-based, they may not detect AWS-specific environment changes or be positioned to do so. They focus on things happening at the host level and the network level, respectively. Subsequently, those mechanisms could miss key changes, either because monitoring AWS is not their core competency, or they're still playing catch-up with their product, or they simply do not or will not support monitoring your AWS environment. Now, we've spent, some people would say wasted, a lot of time trying to figure out what we're going to defend. And it's important that we get a handle on defending our AWS environment, and that entails understanding what's important about our AWS environment, what we should be paying attention to. It's key to architecting our defense, and then ultimately establishing controls. So getting this done soon, as opposed to later, is probably a good idea. And finally, this should not come as a surprise to anybody. As adversaries attempt to improve their own capabilities, they too realize the power and value of cloud computing. You want to thwart the bad guys, and you want to thwart their attempts to access your AWS environment, and obviously the capabilities that it affords. Now, what are we going to be covering today? So we're going to geek for a bit. We're going to get some nomenclature out of the way. We'll talk about traditional intrusion detection mechanisms, systems, the nuance of detecting intrusions in your AWS environment. We'll dispel a couple myths regarding intrusion detection in AWS. We'll identify a couple key architectures that you can use for traditional IDS deployments. We'll talk about a few of our technology partners' products as well. Next, we'll discuss several aspects of computer and network intrusions that are universal and that you have to be aware of if you're going to be architecting for detecting intrusions. Similarly, we'll make sure that you have additional AWS-specific prerequisite knowledge, point out how you should be leveraging a number of the security-related features that we have. And then the meat of this talk and the fun stuff is going to be the description and demonstration of several AWS-specific intrusion detection points and mechanisms that you could and should leverage for your AWS environment and to complement traditional IDS deployments. And finally, we'll mention some important security benefits and resources for AWS customers. We'll wrap it up, and ideally we'll have enough time to take some questions from you. So let's get to it. I'm going to predict that. Can you have your IDS in your AWS? Yes, that's the short answer. But the longer answer involves evolving your understanding of what an intrusion detection system is. So what is an IDS? If we break that down in terms of an acronym, we have a system or a system of systems that monitors one or many aspects of our environment, alerting us to when an intrusion has occurred or is in process. Now, your IDS is for you, not necessarily the compliance guy. It's there to help you combat threats in your environment, whichever or wherever that environment may be. The IDS that is designed for you and in your on-premise environment takes advantages of the features of that environment. In many cases, this is simplified to finding a network choke point, setting up a spanning port, plugging in a rackable, stackable metal box that streams any number of different alerts.
Beep.
Just as Werner, though, regularly tells us to eschew lift and shift architectures, actually take advantage of the AWS environment, re-architect our applications for the AWS environment. We have to think about intrusion detection in the same manner. We want to make sure that we're developing something that takes advantage of AWS features. So if we take a step back and we understand what an IDS is, what it is for, we can confidently say that your IDS for your AWS environment may not look like a traditional intrusion detection system, and that's absolutely okay. So Greg's going to talk to us a little bit about how an IDS in AWS is going to look different.
So you may be used to traditional IDSs. They come in two primary flavors. You've got your host-based intrusion detection systems, and then you have your network-based ones. So host intrusion detection systems monitor typically the state of a running OS, processes, files on disk, configuration. The network ones look at packets, flows in and out of a network. Just as your host-level IDS doesn't look anything like your network-level IDS, when you're building an IDS for a cloud environment, that too will look somewhat different than what you're used to. Here, you're going to look at things like the infrastructure configuration to make sure that your application on top of that environment matches your expectations. You're also going to want to pay particular attention to the security controls within that environment.
All right, so when we look at a box, and we know that we deploy an agent on a box to look for intrusion detection events, and if we plug something into the network in a spanning port, and we're looking at packets on a network, what's the equivalent of essentially a spanning port within an AWS environment?
So this is an overall diagram of what your application might look like deployed on top of AWS. At the bottom, you have the AWS services. Under the shared responsibility model, we manage them, we secure them. You don't have to worry about those. On top of that, you define configuration that is really the architecture of your application on top of those services. That's things like your EC2 security groups, your S3 buckets, beanstalk applications, the definition of what your application looks like on top of AWS. And then on top of that, you may have resources like EC2 instances, S3 buckets, or other components used by your application. So your traditional intrusion detection system might run on your EC2 instances, might monitor flows in and out of your VPC, but that's only part of the picture. What we really want to talk to you today about is monitoring and managing the overall configuration and definition of your application on top of AWS.
All right, so to be clear, we're talking about something that is not a traditional IDS, not the same rackable, stackable, network sniffing box that streams alerts night and day, something that we've grown to love so much in our on-premise environments. The idea of an intrusion detection system in AWS that breaks from tradition and instead takes advantage of features in our AWS environment. That's different. It's something that we need to become comfortable with. But evolving our understanding of what an IDS for AWS is does not mean that we have to go cold turkey on traditional intrusion detection systems. On the contrary, traditional IDS has its place in AWS, if even simply for compliance's sake. For example, who here has attended this talk because your compliance regime mandates that you do intrusion detection within whatever environment you're running a compute system? All right, no worries. We're not spending a lot of time talking about traditional IDS, but we're going to cover that quickly. So, for IDS purists, you can deploy any number of classic traditional intrusion detection systems, these metal boxes that you plug in, inspecting all traffic flowing to and from your VPC at your on-premise VPC endpoint. So, if we look at this diagram here, we have our VPC on our left, we have our traditional data center on our right, we have a termination of the VPC endpoint within our data center, we may have an internet uplink at our data center going to our upstream provider. We absolutely have the power, the technology to put a spanning port there, sit off any number of metal boxes, inspect that traffic. Similarly, when you've configured VPC to leverage the internet connectivity of EC2 itself, you can deploy an IDS at a NAT gateway instance. Or you can do on-instance monitoring with host-based intrusion detection systems. Now, whether it's on-premise monitoring at your VPC endpoint, or you're doing something in the cloud with a VPC NAT gateway or on instance, we have numerous AWS technology partners. A number of them are here at reInvent. You should visit their booths, or you can go to the AWS Marketplace. If you go to the AWS Marketplace in particular, aws.amazon.com/marketplace, you can find a number of these vendors with ready-made products to deploy within your AWS environment for traditional intrusion detection systems. But again, that's traditional IDS, and what we're going to be talking about is something that's much broader, something that's more important for you in your AWS environment, and that's looking at that configuration layer. So we're going to discuss several phases of computer and network intrusions that are universal, whether it's in your on-premise environment or it would be in a cloud environment. Now, our understanding here is what's going to help us focus our cloud-based intrusion detection efforts. Now, when we're dealing with an adversary, he follows a school of root. He has several different things he wants to achieve. He wants to gain access, he wants to maintain access, and he wants to steal stuff. From our understanding of how an attacker actually operates in those three phases, we focus our mechanisms, allow us to detect intrusions for each of these phases within the AWS environment. All right, so before we can begin with the school of root, looking at the actual phases of an adversary as he attacks an environment, we want to actually look at prerequisites that we should be familiar with and apply, certainly, before we start looking at cloud-based intrusion detection mechanisms. So, Professor Greg, working on identity and access management, can you talk to us about a few of these prerequisites and what we should be doing before we start geeking on cloud intrusion detection?
Sure. So intrusion detection is always done with respect to some defined security perimeter that you seek to defend. It is far easier when you have a well-defined perimeter, and proper configuration of an environment can define many things that could go wrong out of existence. So there are a lot of things to keep track of, but overall, you'll want to ensure that all of your components are running as individual identities with the minimal set of permissions that they need to accomplish their objectives. Rules for EC2 is highly recommended in that it will allow your code to run on EC2 with the permissions it needs. We will deploy credentials for you. We will rotate them every few hours. A lot of things that could go wrong around credential handling just go away. We also recommend turning on MFA, which is multi-factor authentication, for any privileged accounts within your environment. Passwords are notoriously weak. You do not want your environment to be vulnerable to the weakest password chosen by one of your administrators. S3 bucket logging is available, and if you are storing sensitive data in S3, we highly recommend that you configure it. That way you have detailed records of all access to that data. We recommend the IAM Top 10 Best Practices talk that was yesterday, so you can catch the video of that. We'll also be handing out reference cards after the talk if you're interested. But beyond those that we expect you may already be familiar with, there are three more building blocks that we want to talk about today. So the first is a security role. So if you're managing the security of many AWS accounts, say you have multiple production stacks or you have departmental accounts, you're going to need access to each of those accounts to enable you to monitor its configuration and security. Don't go set up a database of credentials. That's one more target that you have to defend. Instead, create a security role in each of the accounts that enables your central security function to monitor each of those accounts, discover the configuration, ensure that the security controls are working the way you expect. So we've got a link to the getting started information on roles, but let's dig in a little bit more since we've been receiving feedback that a lot of people are not familiar with roles. So what's a role? A role is a named IAM entity. It is similar to a user, except that it doesn't have credentials. Instead of credentials, it has a policy. That policy controls who can use the associated permissions. So most places that you could create a user, you can instead create a role, and the name of the role isn't a secret. You can freely distribute the name because the policy on it controls who can use it. So
All right, Greg here was kind enough to create a security role. I'm going to leave it up here for another 5 seconds to give you enough time to write it down. Don't worry, we're actually going to make sure that we provide this after the talk. We'll give you Greg's email address, and you can all ask him.
No, actually, it's linked on the bottom of that slide.
Seriously, here's the URL for this security role. Greg, can you explain a little bit more of what we're doing here?
Sure. So this is the S3 section of the policy that we had up earlier, and it's similar structure for each of the services. And if you look at this, it's granting access to the S3 configuration APIs that let you view the security state, view the bucket policy, view the resources that exist. But just as importantly, we told you earlier, everything should run with least privilege. Well, your security audit function probably doesn't actually need to view the content that you're storing, so you'll notice that we're not actually granting access to the content itself, just the security configuration.
I think next week we're releasing security role as a service. Essentially, Greg just stays online all the time while we release new features and services and updates that security role.
So now demo time.
Yeah, sure. So Greg here is going to actually show you setting up the security role within an AWS account.
So I'm in the IAM console here. I'm going to go into roles, and I'll create a new role, and let's call it Sec Audit 3, because I may or may not already have one. And then we're going to pick role for cross-account access between accounts that we own. And then somewhere around here, I have an account ID. So this is, again, a public value. It's the 12-digit ID for the account that I'm going to run my security monitoring from. And I'm going to put in a custom policy. Let me not retype that. And you can see that's the same policy that we had up. Create role. And now I have that role within the account. So another thing that's a useful building block is write-once storage. You might, at some point in the past, have actually, when you built out a server, written some of the configuration metadata to a CD, file hashes, that sort of thing, or some other media that you can then mount read-only to enable you to monitor changes and yet ensure that those authoritative records for the correct configuration weren't altered. So attaching CDs is a bit of a pain when you're dealing with EC2. So instead, we're going to use S3. And there are a couple different ways that we can configure S3 to support this abstraction of write-once storage. So the first thing that we're going to do is we're going to turn on bucket versioning, which ensures that when you overwrite an object, the previous version isn't modified and is still available. We'll also turn on MFA delete to prevent deletion of previous configuration information. Most of the things that we're going to write here are very small. There's no reason not to retain them indefinitely. And then if you want to maximize the amount of security isolation that you get, create a second account. Put the authoritative records for monitoring the state of your environment in that second account. Attach a bucket policy granting access only to the put object APIs so that you can ensure that even in the event of any compromise to your production account, you have authoritative records on the configuration. So this is a bucket policy that might do such a thing. You can see here it's an allow to some other account, get object, put object. Just as important, I'm not including access to any of the modification APIs or anything to let you muck with bucket versioning. For those of you who haven't seen the versioning UI before, it's in the S3 console. It's under bucket properties, and you just have to select enabled, click OK, and then your objects can't be modified. You'll just get new versions.
So we've got the security role as one. We've got using actual write-once storage or developing write-once storage with S3. And then our third?
Oh yeah, CloudTrail. So for those of you who missed it in the keynote or the session yesterday, we announced that we're now giving you API-level logs of all actions taken in supported services. Just as we did with S3 bucket logging, we'll stream sets of these to your bucket so that you can see all the calls that have happened in your account. These are delivered about every 5 minutes. I think the target is delivery within 15 minutes of the call. You can configure SNS notifications every time we give you these. It's currently supported in US East 1 and US West 2. These are the services supported. Additionally, if requests are made through a higher level service, we'll show you that too. So turning it on, just go into the console, CloudTrail enable, yes. If you already configured write-once storage, as we recommended earlier, well, send your logs there. Ensure that even if something goes wrong, no one can tamper with your logs of what happened. Just like you do off-box logging with syslog for your hosts, do off-account logging for your audit logs. So what's in the logs? We'll tell you who made the API call, when the call was made, what the call was, resources acted upon, where the call was made from. Don't yet tell you why the call was made, but you can usually ask the person who made it. So here's an example of the identity section for an IAM user. You can see here that Bob made this call, and we'll give you additional details like the access key ID, so that if you had a credential exposure, you could hone in on records created with the exposed credential. This is an example of a federated user, and you can see here that in addition to the federated identity itself, we'll also tell you the session issuer, which is the user that created that federated user. This is what it looks like when the call was wrapped through another AWS service, like Elastic Beanstalk. And then, of course, timestamp, ISO 8601, clocks are synchronized, about what you'd expect. We'll give you the details on what service was called, what the change was, what resources were affected.
All right, so now that we've gotten the prerequisites out of the way, we'll go back to the schooler root, and we'll start talking about the phases an adversary may be in when he's trying to gain access and or maintain access within an AWS environment. It turns out that the technology or the configuration variables that we'd like to look at to either, one, determine if somebody's gained access or if they're trying to maintain access, we can actually look at the same areas. So where are we actually going to be looking to find out where somebody's gaining access or maintaining access within an AWS environment?
So again, it's all about the security perimeter. If you're looking at a host, that perimeter will be things like listening ports, etc password entries, PAM config, SSHD config. On your cloud environment, it's all about credentials that are used to access your resources, as well as resources that may be accessible from outside your account. So there are a couple types of each, and let's dig in a little bit on credentials. So we support login profiles, which are username, password pairs used to access the management console. We have access keys, which are HMAC signing keys used to make API requests, X509 certificates used for SOAP, CloudFront RSA keys, as well as temporary security credentials. These can be attached either to the root account or to an IAM user within the account. You'll want to know what credentials are out there with access to your account, that they're being managed properly, and that new ones haven't been added that you didn't expect. So we're going to go through actually looking at the credentials attached to a user. So again, within the IAM console, loading up a user, and we can see here under the Security Credentials tab, this user has 2 access keys, doesn't have a password, doesn't have any X509 cert, and isn't using MFA, which is expected because they don't have a password. One particular thing to pay attention to is whether a password gets created on a user that you expect to be for programmatic use only.
So such as a web server.
Yeah, your web server probably doesn't need a password. It probably doesn't log into the management console. Yay. So beyond credentials, most AWS resources are only accessible within your account. There are some that can be configured to be publicly readable without any credentials. That's useful, for example, if you're intentionally hosting a website out of S3. On the other hand, you want to ensure that any data that you intend to keep private isn't configured for public access. Additionally, there are certain types of resources that can be configured to be shared with other accounts. This is typically done by attaching a resource level policy to that resource. These are things like S3 bucket policies, SQSQ policies, SNS topic policies, and because these policies control access to resources and can grant that access from outside of your account, they form part of the security perimeter of your account and therefore are something that you're going to want to monitor for changes.
And if we want to actually check for cross-account access?
So I'm going to go into the S3 console and pull up a bucket. Here's a bucket. Pull up the properties on that bucket. And over here, I'm going to edit the bucket policy. You can see here is an example of a policy attached to an S3 bucket. So we also talked about roles earlier. We showed you how to use a role to enable access so that your security audit function can have access to run certain APIs within your account. Well, that's another thing that you're going to want to pay attention to and ensure that any roles that are configured that allow some other account to do things inside your account actually represent authorized access. So going back to the IAM console, going back to the IAM console, I'm going to go into roles, and let's pick a role. No, let's look at the security audit role we created earlier, trust relationship section, and here you can see the account. We could also pull up the actual policy that governs access. It should look familiar. So we've talked in a couple of contexts about access policies. Our policy language is quite powerful, and there are many ways of representing elevated access within an account. So when you're looking at an access policy, beyond thinking about what can be done currently with the policy, you should pay attention to the access that can be implicitly granted by the policy. So users that have access to call assorted identity and access management APIs can do things like reconfigure the security of your account. And for example, a user that can update a policy can write whatever policy they want unless there are restrictions in place. Or, Bob may not be an administrator, but if he can reset the administrator's password, well, he's an administrator. There's a link on the slide to the policy simulator, which is a tool we released a few days ago to help you understand policies. But now for the quick quiz segment of this talk. So we've got 3 policies up. Who here thinks that policy A grants the user to which it's attached effectively full access to the account? One hand, 2 hands. Okay. Who here thinks policy B grants full access to the account? And how about policy C? Okay. Yep, all of them. So let's walk through each of them slowly. So policy A, first statement, SNS star. Wouldn't call that full access. Can muck with notifications. Let's look at statement 2. Action, S3 star, resource star. Okay, S3. Oh wait, what's that star after S3 star? Yep, that's access to everything. Funny, the highly privileged operation isn't at the top of the policy? Who would have thought? Policy B. So, first statement, again, harmless. In this case, totally harmless. Not action star. That doesn't do anything. Second statement, this user can put user policies on any user. Well, what does that mean? They can rewrite their own policy to do whatever they want. Let's look at policy C. So this one's a little bit trickier. This policy allows launching EC2 instances and allows passing any role in the account to the EC2 instance. So a user with this policy can launch an instance that has credentials delivered for any role in the account. It may or may not be full access depending on the level of privilege associated with the most privileged role in the account. But just as you should think about ways that access could be elevated by someone with the access, you also want to think about how future changes to the configuration of the account might unintentionally increase privilege. So for the sake of audit, I would consider the user with policy C to also be fully privileged.
All right, Greg, that was a lot of stuff that we're checking for. We're diving into the management console, we're clicking on users, we're clicking on roles, we're checking for public resources. That's a lot of clicking. How are we supposed to do that regularly? I'm already tired hitting refresh on the main page to see what features and services we're releasing.
So you can do effectively everything you can do from the AWS Management Console via either command line tools or via APIs. So you can script all of this. And we actually have example code here for how you might grab some of this data. There's also a link at the bottom of this slide to a sample script that'll monitor a lot of the things we're talking about now. So the code that hasn't loaded yet walks you through enumerating S3 bucket policies, and you can see it pulls a list of buckets. For each bucket, goes through, pulls the policy. We generally find it easiest to actually output a hash of the policy instead of the policy itself. So the script that we have down there will actually just dump out a CSV format list of a whole bunch of things that grant various levels of access so that you can store it, diff it, that sort of thing. Here's the IAM user section. So again, enumerate through all the users, pull all the policies attached to each user, print them out. And we'll do this for users, groups, roles, EC2 security groups, dump it out, flat file, write once storage, diff it, do this daily at least, find changes, make sure that they're changes you intend. We recommend actually customizing this for your environment because each environment is different. There are things that you expect to change every day. For example, in my account, the list of instances in a particular security group is highly dynamic, so that isn't something that I would necessarily alert on changes. But if my user policies change, well, that's interesting.
So we actually show an example of this.
So what we're going to do here is, can anyone actually see that? Okay. So I'm going to actually run this, and this will iterate over, pull out a lot of the stuff that we talked about earlier. And while that's running, I have a previous copy. So I'm going to actually go in and, oh, actually, I created a role, so we should see that here. So if I run this, redirect it to a file, and then diff it against the previous result, we should see exactly what changed in the account. Let's let it run. Sorry, I can't really see the screen.
2 and 3.
What did I do?
2 and 2.
Oh.
They're not going to be different.
Okay. So here we can see that a role was created. It had a policy attached to it, hashes of the policy.
So in this case, we could actually schedule this, run it regularly, and anytime we would actually see a diff or a change, then that would be something for us to investigate.
So example usage for the script. Again, use a user role, run this from a central account. Just keep a list of roles that you want to monitor rather than a list of credentials. Here's a bigger font, some of the details. So you can see here we've got buckets with and without policies, queues with and without policies. Again, bigger font on what an earlier diff looks like. In this case, a policy was added and a policy was changed. I can then go in and look at what the changes actually were.
All right, so we've talked about things that we need to have as prerequisites for cloud intrusion detection. We've talked about important places where an adversary may want to gain access or attempt to maintain access. We've talked about how to go and monitor those particular areas, determine whether or not there's been a change that we'd like to go and investigate. Let's moving on to the next phase of our school of root. Our adversary wants to steal stuff. And when I say steal stuff, what does that actually mean in the context of your AWS environment? What is the stuff? How can we detect that somebody is actually making off with it? Well, an obvious candidate for the stuff is your data. But there's already S3 bucket logging. We've given a shout out to that. A non-obvious candidate for the stuff are access to the AWS resources themselves, your actual compute, your actual storage capabilities. How can you actually detect that somebody's making off with your resources? I give you crazy detection, something that's a little bit out of the box, but we've probably seen this before. This is a text message that I got from Verizon on the 4th of the month, when my bill's due at the 25th of the month. And that was a little interesting. And after investigating this particular event, turns out that we were running streaming audio at home over LTE as opposed to the local Wi-Fi.
Told you I didn't do it.
And if we apply this same sort of concept to our AWS environment, it absolutely makes sense. There's a certain amount of spend that we expect over time. And when we see something that goes above that expected level, we'd like to alert on that. We can tell that something is either okay, as it's below the actual spend level, or it's something we want to go and investigate. And so AWS actually provides billing alerts. This is a strange intrusion detection mechanism, but it's absolutely sane. There's no need to wait to the actual end of the month to become aware of unexpected utilization. What you want to do is establish a baseline of known good billing over time. Set some thresholds for yourself, overall or at specific periods. You investigate these alerts, try and determine root cause. The simplest cloud intrusion detection mechanism, and for free tier accounts, it's actually free. Setup of 10 alarms and 1,000 notifications, standard usage charges after that. Now, before you can actually create an alarm associated with billing and estimated charges, you have to enable monitoring. When you enable monitoring of your estimated charges, this creates metric data that you can use to create the actual billing alarm. So it takes about 15 minutes before you can view billing data and create alarms using the Amazon CloudWatch console. To enable monitoring of your estimated charges, just log into your AWS account. Under Account Activity, in the Monitor Your Estimated Charges box, click Enable Now. There is a wizard for actually creating billing alerts in the Amazon CloudWatch console. You can use command line interface as well. You can apply more than one action to an alarm. You can set the alarm to be triggered so that you receive an email notification for a specified service exceeding a certain amount. You can create a billing alarm under the Create Alarm wizard. In this example, you can graph your charges for Amazon EC2 over the last 14 days and then set an alarm that sends the email as soon as your charges exceed, say, $200. So the wizard actually is pretty simple. Under Billing by Service, you select a service, EC2 in this case, view its billing data in the graph in the lower left pane. You click Next in the navigation pane. Note, there's several different ways that you can actually view billing data for your account. So there's total estimated charges, there's by service, or there's by linked account. So for customers who have consolidated billing, you can actually use this as, again, a sort of security role that has an overview in terms of intrusion detection, but using billing alerts as a mechanism across all accounts. So it's fairly simple. In the alarm threshold pane, in the name box, you create your name, you create a description, and then under whenever charges for, in the drop-down list, you want to actually select the greater than or equal to sign and then specify a dollar amount. You can set this to go to an SNS topic, and you can subscribe to the SNS topic. Remember that SNS will actually send out confirmation emails that you actually have to confirm that you're going to actually subscribe to that SNS topic. It's important to go and actually monitor the email address that you're going to be sending these alerts to. Beep. It's not like an IDS console. You can also use the command line interface. This is an example of following a procedure that creates an alarm that will send an email message when your estimated month-to-date charges for Amazon EC2 exceed $200. And the same example is actually in our documentation for the Amazon CloudWatch CLI. Now, assuming you anticipate you've got $1,000 a month that you're going to spend, how could we actually set something up that's a little bit more heads-up awareness for ourselves? So we've got week 1, week 2, week 3, week 4, and we expect that we're going to hit $1,000 by the end of the month. Set it up in $250 increments. We'll ladder a set of billing alerts for ourselves at $250, $500, $750, and $1,000. And naturally, as our billing increases over the month, we're going to break through those thresholds. And ideally, we're going to break through them at normal intervals, and that's okay, right, when we see that happening. So we're getting the alerts, but we may not actually go and investigate if we are expecting those charges at that particular point in time. And you can certainly set up a greater frequency than this. And you can do some back-end logic to actually determine whether or not you're going to set off the pagers. Now, early alerts are what are interesting. So you get to day 7, you're breaking through 250, no problems. You get to day 9, you're breaking through 500, that might be something that you're interested in. More than one early alert, where you're breaking through 250, 500, 750, remember, that alert that's right there, that's something that you might want to go and look at. And you want to do this before the end of the month, right? We have a good bit of documentation on this. We have monitoring your AWS charges, and in addition to that, we have the command line interface for this. We have examples for actually setting up billing alerts and using those as an intrusion detection mechanism. While we don't specifically call it out in that documentation, I think it is pretty natural. Additionally, if you want to get a little high speed, create your own meter-based alerts. You can actually use programmatic access to billing data. So access your billing data through an API, pull it down, it's in CSV format, gives you greater detail with regards to your usage, and more importantly, specific to regions. So let's say you have EC2, you know that you're running it in US East, but you're not running it in EU West, and then you see a charge that's greater than 0 in one of the regions that you know you're not running instances, that's probably something that you want to alert on. Now, while we've walked you through ensuring that your infrastructure is configured the way that you expect it to be, if that infrastructure includes EC2 instances, you can obviously use the traditional approach in terms of host-based and installing intrusion detection mechanisms on the actual host. But you should also think about tactics that you can use in the AWS environment, advantages in the AWS environment at your disposal. Most importantly, the ability to rebuild frequently. There's no reason to have long-lived instances that build up cruft, system rot, things that will make it much more difficult for you to investigate and determine what's actually happened. Rebuild your instances daily, and if anything does happen and you have to go and investigate, you've got a day's worth of information to have to go through as opposed to months and months and months. So use the advantage of the AWS environment to actually create tactics that will make it more difficult for an adversary to maintain access within that environment. It's difficult for them to maintain access when the EC2 instance disappears. So Greg and I, we've instructed you on monitoring and defending your stuff. We told you that you should do this and that you should do that, but that doesn't mean that we're lying down on the job. Beyond keeping an eye out for AWS and looking out for customers, we actually do some regular checks that we perform on behalf of customers for their environments. Those folks who are premium support customers also have access to Trusted Advisor. This inspects your AWS environment, not only telling you where you can save money, but it'll also let you know when your security groups might be a bit more open than necessary for your applications. Your bucket policies may allow a bit more access than you would prefer, or whether or not you're using MFA. Here's an example of the Trusted Advisor dashboard. And you'll notice that there's a security tab. If you actually click on that security tab, you'll see a number of different checks that AWS is performing on your behalf. So we'll check security groups for rules that allow unrestricted access to specific ports. We give you pretty simple green, yellow, red status. We'll give you a green, no issue detected if access is allowed to port 80, 25, 443, things that are common for your actual AWS environment when you want to allow those access to those ports to the world. But we'll give you a red action recommended if you have access to port 20, 21, 3306 for your database. We'll give you a yellow investigation recommended for other ports. We'll also check for your AWS identity, use of AWS identity and access management. We'll give you a yellow investigation recommended when no IAM users, groups, or roles have been created for your account. Then we'll check buckets in Amazon S3 that have open permissions. We'll give you a yellow if that bucket has list access for everyone. But we'll give you a red action recommended if a bucket has upload or delete access for everyone. We'll also check the root account and warn if multi-factor authentication is not enabled. And we'll check your password policies too. Now, we've talked about a lot of things that you should be monitoring. You're going to roll your own. You might have an IDS that you're running that you're investigating alerts for. You might set up billing alerts, and that brings something to your attention, something that goes bump in the night, and you don't know what to do with it, and you haven't figured out or you haven't defined essentially like a run book for that particular thing. Do not hesitate to get in touch with us. Contact us. More specifically, engage support. Support is actually your convenient first point of contact to make us aware of your concerns, whether they're associated with your AWS account in general or they're security related. More importantly, if support cannot immediately address your concern, they know who to engage and escalate to internally at AWS to help you figure things out. They are specifically trained to actually escalate security concerns to the AWS security team. So make sure you engage and utilize your support mechanisms. Other resources that you have to be aware of: the security blog at AWS's blog. Plenty of information regarding security best practices at the AWS Security Center. And then, of course, if you have any security concerns specific to the AWS platform that you'd like to report, don't hesitate to contact us at the AWS security team, aws-security@amazon.com. Now, in addition to, you may have seen it before, the best practices or the overview of security processes at AWS Security Center, earlier this week we actually released a customer-focused security best practices white paper. This is meant to help you design security infrastructure and configuration for your AWS environment. It's high-level guidance for managing accounts, managing OS-level access, securing your data, but it also goes into managing security monitoring, auditing, alerting, incident response as well. We also cover other topics such as DDoS, and we cover a number of different things that you do within particular services to achieve certain security objectives. And that paper is available now. So key takeaways: beyond traditional IDS, we've got cloud IDS. And it's going to look different than a traditional IDS because it's leveraging environment variables in the AWS environment. Now, we also provide a variety of mechanisms and support that you should be leveraging to monitor your security controls. The big takeaway here is that we want you to experiment with this. I want you to play with the actual features that we have here, and we want you to give us feedback. Tell us what you'd like to see. You can see that CloudTrail is something that we've delivered for customers, and that's based on feedback. The more that you give us feedback, the more that we're going to do things for you. And you should absolutely approach some of the partners that we have in the vendor area. Talk to them about incorporating some of the ideas that we talked about today in their products, such that you can leverage them directly from the marketplace. For those people that were looking for those links again with regards to downloads, we've got both the role policy for those folks that want to create the security role for their account, and then we've also got the script that will actually go through and enumerate a number of different things. Greg will update it frequently as we add new services.
I think it's already out of date based on the announcements yesterday.
And with that, I want to make sure I remind you guys to give us feedback on this presentation, and we're happy to take questions from people.